Dear learner, in continuation with my class of the yesterday, in this class I am going to talk about the independent sample t-test for the small sample. As we are aware that the independent sample t-test is used when we are having normally distributed data and the data is in the form of the interval or ratio scale, and our data is not violating any of the assumption of the normalcy. So in this class I will be talking about the independent sample t-test for the small sample, and I will start with the example. A US magazine Consumer Reports carried out a survey of the calorie and sodium content of a number of the different brands of hot dog. There were two types of hot dog, beef and poultry. The results below are the calorie content of the different brands of the beef and poultry products. And here we are having the data for the beef hot dogs and the poultry hot dogs. And with the help of this data, in the first sample we are having the 20 and in the second sample we are having the 17, and the sample mean is 156.85, okay, for the beef products, and for the poultry products the sample mean is 122.47 and the standard deviation is 22.64 and 25.48 respectively. So with the help of the above data, we can have the mean difference, that is the x1 minus x2. It means the 156.85 minus 122.47, that is equal to 34.38. Okay, when the standard deviations are approximately equal, so we can calculate we can say the adjusted standard deviation, or we can say the combined standard deviation. And we are going to put our mean and standard deviation score into the formula, and with the help of this formula we are going to get the value of the t for the small sample independent t-test. As we are looking into the formula, the issue of the t is like this. The standard deviation is equal to under root n minus 1 square into sd1 square plus n2 minus 1 into sd2 square upon n1 plus n2 minus 2. And with the help of this we are going to get the value of the standard error, and with the help of this standard error we are going to get the value of the t. Okay, the general formula for the t is equal to d upon SEMD, and d is the difference between the two means. And here if we are going to put the values of the t difference and the standard error of the measurement, we are going to get the value of the t. Okay, that is the 34.38 upon 7.91. If we look up in the tables of the t distribution with the 35 degree of freedom, we find the value of the p, okay, that is higher than the 0.001 level. Therefore there is a strong evidence that the calorie content of the poultry and hot dog products is lower than the calorie content of the hot dogs which is made of the beef. Okay, with the help of this example we can have any type of, if we are having any type of the data with the small sample, so in that case we can get the value of the t, and we can reach on the conclusion that whether the true difference exists between the means of the two small sample or not. Okay, there are a number of the factors which can affect the power of the independent sample t-test, whether that is the large sample t-test or the small sample t-test. Okay, first one is the sigma square or the SD square. Okay, a decrease in the SD square increases the calculated t and therefore increases the power. It means if the value of the standard deviation for in either or both the sample is low, in that case we are going to get the t value which is of the high strength or of the high power. Another one is the alpha. Okay, for an increase in the alpha, although there is an increase of the probability of the type 1 error, and if we are having the t is, if we are have the smaller t, therefore there is the greater likelihood of obtaining a significance and therefore an increase in the power. Another very important factor is the sample size. Okay, if we are having the bigger sample size or the larger sample size, we are going to have the value of the t which is having the more power. And another very important component is the one-tailed hypothesis. It means that in one-tailed hypothesis we are having the direction in the relationship. What does it mean? It means that we are having better chances of getting a difference in comparison to a two-tailed hypothesis which can go either way. It means if we are going for the one type of the one-tailed hypothesis, it means we are going to have the better chances of getting the true difference. Okay, after discussing the independent sample t-test for the large sample and for the small sample, now we are going to talk about the significance of difference between the two correlated means. What does it mean? Actually, the mean of the correlated means is how the two sample or the mean of the two sample or the data of the two sample are related. A paired sample t-test is used in the repeated measures or the correlated group design, in which each subject is going to be tested twice on the same variable. What does it mean? It means that in psychology we are having different type of the situation where we are interested in looking into the effect of the training or the effect of the medicine, and we want to compare the two situations. First situation is before the administration of the test or before the administration of the training, and another situation is after the administration of the training or learning. And we are interested in comparing both the situation, and we are interested in knowing that what is the effect of the training on the performance of the individuals, or what is the effect of the drug or medicine on the individual. In that, it means we are having a single sample, one sample, and we are having two different situations. One is before the administration of the intervention, and another is after the administration of the intervention, and we want to compare the effect of the training or effect of the learning or effect of the medicine. And with the help of knowing the differences between the two situations, we can know that what has been the effect of the intervening variable. Another situation can be like this: when we are having more than one sample, and we are having the data from more than one sample, but all the data, they are almost equivalent. Equivalent means equivalent with respect to the mean value, equivalent with respect to the standard deviation. A common experiment which is related to the two correlated means is the before and after design, which I have discussed. The test can also be used for the match group design, in which we are having the subjects in pair and that are matched with respect to certain characteristics like IQ, grades, and the mean score and the standard deviation in the two conditions. As the subjects in the groups are matched and not independently assigned, this design is also referred to as the correlated groups design. The matched sample or the paired sample t-tests are considered more powerful than unpaired sample t-test because using the same participant or item eliminates variation between the sample and could be caused by anything other than what is being tested. it means that we are having the certain advantages of the paired sample t-test over the independent sample t-test, where we are having very much possibilities of getting the different type of the data in terms of the mean and standard deviation, even if we are getting the data from the same population. As I have already discussed in the earlier lecture, that if we are getting any type of any data from the same population and 10 researchers are getting the 1% of the representative data from the same population, in that case the each 1% is going to have the different mean values and the standard deviation value, and that is going to create a lot of difference in the t-test. Okay, there are certain requirements and assumptions of each type of the statistical test, and if we look into the what are the requirements of the t-test with the correlated means, the first one is the two sets of data must be obtained from the same subject or from the two groups which are matched or paired. If we are getting the data from the same subject, in that case we are not going to have any type of the inherent discrepancies or variations in terms of the mean score or the standard deviation score, and if there is any type of the difference, it can be attributed to the effect of the intervention or effect of the manipulation of the independent variable. And in the case of the matched group or the correlated group, we are going to match the group with respect to the certain psychological attributes or the traits or the characteristics, and we try to focus on the fact that all the groups must be matched in terms of the mean and standard deviation values. There are certain assumptions which are again associated with the use of the t-test with the correlated means. The first thing is the normalcy. If we are having any data which is not fulfilling the assumption of the normalcy or the normal distribution of the data, in that case we cannot go for the parametric type of the statistics, and of which the t-test for the correlated means is a part. And the second one is the sampling distribution of difference score should be again normally distributed. It means कि whatever difference we are getting in terms of the mean differences, they should also be normally distributed. The third assumption is basically associated with the dependent variable, the continuation, or we can say the type of scale we are using for the dependent variable. All the data should be either in the interval scale or it should be in the ratio scale. Another very important assumption is associated with the outliers. Outliers are basically the extreme scores. As we all know that any type of the parametric statistics is going to be affected by the extreme scores, because we try to reduce or minimize the value of the variance or standard deviation, okay, so that our data can qualify the normalcy of distribution. So okay, for this we try to have the data which are having no outliers, and if we are having any outliers, we should try to eliminate the outliers, and or we should try to reduce the value of the outlier with the help of how we can adjust the values of the outliers in terms of the extreme scores or the highest value of the standard deviation. If we look into the paired sample t-test, basically it requires the data to be numeric and continuous. As it is based on the normal distribution, continuous data can take on any value within a range in terms of the income, height or weight. The opposite of the continuous data is the discrete data, which can only take a few values like high, low, medium. Occasionally discrete data can be used approximate a continuous data, such as with the Likert type of the scale. Okay, this type of the situation arises when we are having very important variables in our study and we want to consider, we want to consider the data, and in that case we can change our we can say the discrete type of the data into a continuous scale, and in that case this type of the data can be included into the paired sample t-test. Okay, the hypothesis issue or hypothesis testing type of the issue is very much associated with the correlated sample t-test or the mass sample t-test, because in independent sample t-test we are having certain assumptions, and in the case of the paired sample t-test our assumptions are a bit different. Like many statistical procedures, the paired sample t-test has the two competing hypotheses, the null hypothesis and the alternate hypothesis. The null hypothesis assumes that the true mean difference between the paired samples is 0. Under this model, all observable differences are explained by the random variation. Conversely, the alternative hypothesis assumes that the true mean difference between the paired samples is not equal to 0. The alternative hypothesis can take one of the several forms depending on the expected outcomes. If the direction of difference doesn't matter, a two-tailed hypothesis is used. As I have already discussed, if we are going for the one-tailed type of the test, it means that we are sure of the direction of the relationship, while when we are not sure about the direction of the relationship, we can go for the two-tailed type of the hypothesis, in which condition the relationship can go either way. Okay, in the case of the two-tailed type of the hypothesis, upper-tailed or the lower-tailed hypothesis can be used to increase the power of the test. The null hypothesis remains the same for each type of the alternative hypothesis. Okay, in the case of the paired sample t-test, hypothesis can be formally defined as below. The null hypothesis assumes that the true difference is equal to 0. This is the first condition. The two-tailed alternative hypothesis assume that the mean difference is not equal to 0. This is the second type of the condition or the hypothesis. And in the third condition, the upper-tailed alternative hypothesis assumes that the mean difference is greater than 0. And the fourth one is the lower-tailed alternative hypothesis assumes that the mean difference is less than 0. So in the case of the paired sample t-test, we can have all these possibilities with the hypothesis, and we can go for any type of the hypothesis depending on the type of result we are going to get, or the type of expectation we have with the study and the type of relationship which has been assumed in the statistical analysis. Okay, now I am going to discuss about the different methods of calculating the t-test for the two correlated means. First one is the single group method, another one is the difference method, and number 3 is the method of the equivalent groups, which includes the two type of the technique. The first method is the single group method for computing the t-test with the two correlated means. The single group method is also known as the single group design. It means कि we are having a single sample or the single group on which we administer the test twice. So what does it mean? It means कि we are having we are going to test the difference between the two situations on the same sample, and it can be a test of the learning, it can be a test of the training, it can be a test of the acquisition of some new skill, it can be a test of some type of the intervention in terms of the some type of the psychological help, in terms of the some type of the intervention with the medicine, but the sample remains the same. And okay, one situation is before the administration of the test or intervention, and another situation is after the intervention, and we try to compare the scores of the respondents or the group on two occasions. For example, if we are intending to find out the effect of the training on students' educational achievement, okay, first we take the measures of the participants' achievement before training, means before the intervention, and then we introduce a training program, and again we take the measure of the educational achievement. In this we have a single group and administer educational achievement test twice. Okay, so here we are having the two situations. One is the situation before the administration of the test or before the administration of the training or intervention, and another situation is where we have already administered the training or the skill development or the intervention, and after that we have got a score on the performance or the educational achievement test, and we are going to detect the difference between the two situations in terms of the educational achievement of the student. And if we are going to get any significant difference, in that case we can say that this difference is because of the intervention or the training done on the student, and because of this intervention we are having a significant increase or significant difference in the educational achievement of the students. Okay, now I will try to explain this method with the example. In order to get the significance of difference between the means obtained in the before training and after training, we use the following method. The standard error of difference, okay, we can get with the formula, that is the standard deviation of the first group. We square the standard deviation of the first group plus the standard deviation of the second group minus 2r into standard deviation of the first group into standard deviation of the second group. Okay, the standard deviation, the SDM1 or the sigma m1 refers to the standard error of the initial test, sigma m2 refers to the standard error of the final test, and the R is the correlation coefficient between the scores of the initial test and the final test. Okay, and when we put all these value into the formula, we will get the value of the T. Okay, here we are having the scores for the single group method. At the beginning of the session, an educational achievement test in the maths was given to the 111th grade students. Their mean score was like this, and the standard deviation was like this. After 6 months, an equivalent form of the same test was given and the mean value was like this and the SD was like this. The correlation between the scores made on the first testing and the second testing was like this. Has the class made significant progress in maths during the 6 month? We may tabulate our data in the following manner. Number of student is 100. First we are talking about the initial test. Okay, mean value is the 5.4, SD is the 7.2, standard error of the mean is 0.72 and the correlation coefficient value is 0.64. And for the final test, the number of students are again the same, that is 100. The mean value is 56.9 and the standard deviation value is 8.0 and the standard error of mean is 0.80. When we put all these value into the formula for the single group method, we are going to get the results like this. The standard error of difference or the sigma d is equal to 0.72 square plus 0.80 square minus 2 into 0.64 into 0.72 into 80, that is equivalent to 0.42. Okay, when we put the value of the SED, standard error of difference, into the formula, in that case we are going to get the value of m1 minus m2 minus 0 upon SED, that is equal to 1.5 upon 0.42 and t is equal to 3.57. The degree of freedom for this method will be n minus 1, that is equivalent to 99. Okay, how these value can be interpreted? Referring to the critical value in the table for the t-test that are given in the appendix of the textbook of the statistics for degree of freedom 99, and find that the value at the 0.05 level is 1.98 and at 0.01 level is 2.63. Our obtained value is 2.35, therefore this value is significant at 0.05 level and not on the 0.01 level. Here we can say that the class made substantial improvement in the mathematical achievement test in 6 months, which is significant at 0.05 level. What does it mean if we are having the value significant at the 0.05 level? It means ki out of 100 there are 95% of probabilities that the difference is coming because of the interventions made in terms of the training on the mathematical achievement test, and remaining 5% we are having the probability that the difference may be because of the error factors. Okay, this is all about the presentation for this class. In this lecture, I have already talked about the independent sample t-test with the small group, and after that I had talked about the correlated sample t-test with the single group method. And as we are aware of the fact that the independent sample t-test and correlated sample t-test, they are having their different uses based on the sample size and based on the characteristics or the attributes of the data. And in this test we can use the single group method as well as the difference method or the method with the equivalent group. And in the case of the small group independent t-test, we are having certain assumptions which can be which are related with the normalcy of the data. Okay, in the case of the independent sample t-test, we take the two sample from the different population and they are having different characteristic and they are having differences in terms of the mean and standard deviation values which are related with this different type of the attributes or the characteristics of the individual in the sample. While in the case of the single group method, we are having the single sample which is going to be tested twice okay, on the different tests, and we compare the two different situations with the help of the t-test. Thank you.